right? So for number 4, 1 minus tan theta. Now for this one, we know that as long as there's tan, there's always a solution which is 90 plus k times 180. But also there are some specific values for theta, even if there's tan, that will make the denominator to be what? A 0. Like here, if you put 45 degrees here, tan 45 is 1. So 1 minus 1 will give you a denominator which is a what? A 0. Which means you also have to get to equate that denominator to 0, then you get its general solution. Right? So you get theta equal to 45 degrees plus k times 180. The k is an integer, right? Then you must also say, or the other one now, which is caused by the asymptotes on the graph. So theta is equal to 90 degrees plus k times 180. Because I'm sure you can agree with me that if theta is 90 degrees or multiples that are a distance of 180 degrees apart, tan whatever the angle there, you get an error, right? What is 1 minus error? It's error or it's what? Undefined. That's why you have to include this. Are you following? So if you get any question on this type of a question here, this is always the first solution, or it's a solution that you must have, no matter what. As long as the identity has got tan, this is one of the solutions. Right? So here we have got 2. Then we also have the second denominator. The second denominator is the difference between cos and sine. So that's 0. So we create tan there, because the coefficient of both sine theta and cos theta are equal to 1. So we have to create what? Tan. So this will be sine theta equal to cos theta. You'll find that this one here will give you the same solution as the first one. Right? So you get tan theta equal to what? 1. Well, I could just write this again as 45 degrees plus k times 180, where k is an integer. So we have two solutions that are identical. Okay? Because in that case, even though this initial equation is in terms of cos, but it can be converted to tan using the fundamental identity. All right? Equation there. The first general solution that we are going to use to determine the exact solution, obviously it's going to be theta equal to 90 plus k times 180. Right? If you substitute k equal to 0, it therefore means that theta will be equal to 90 degrees, k equal to 1, you get 270 degrees. Okay? Right? So we get 2. We'll get 2 solutions for this general solution between 0 degrees and what? 360. Then, the first denominator on the left-hand side can also be 0. Okay? So we'll say here also tan squared x will be equal to 0. Take the square root here, we get tan x equal to 0. So x is going to be shift tan of 0 plus k times 180. What is shift tan of 0? Huh? It will give you what? 0, right? So what that means is that's 0. So this is the same as k times 180, where k is an integer. The reference angle we get here is also a solution. So I'm just going to add it there. Okay? I'm just going to add it there. So 0 degrees also a solution. If you put k equal to 1 here, you get 180. So 180 is also a solution. Okay? So we have got two solutions there. If you put k equal to 2, okay, the 360 is not included. So if you put k equal to 2, it won't be a solution because of the circular bracket. Are you following? Yes. I'm using the general solution, this one here. Okay? Then, we also have the second denominator on the right. So that's cos squared x equal to 0. So cos x will be 0. So this will give us shift of cos, okay, plus or minus. That will be shift cosine of 0, which is 90. So you get x equal to plus or minus 90 degrees plus k times 360, where k is an integer, right? Then you use try and error, substitute the values of k. There are two here. If I put k equal to 0, I'll get 90, which I already have there. So there's no point of repeating it because that general solution gives you a solution which is 90, which is also provided by the first general solution. So there's no point of repeating that. Then, if you put k equal to 1, okay, if you check the negative, you get the 270, which we already have, right? If you put k equal to 2, no solution, minus 2, no solution. Because the first general solution already gave us the 90 and the 270. This one here gives us the same values. There's no point of repeating them. Okay? So the 4 solutions are going to be those ones. Are you following that? Are you following? Is it making sense? Yeah, there's no point of repeating values that you already have. Writing these two, then you write them again. There's no point. All right?